A very welcome to all Cambridge students. Hi, this is Surendra Bora, teaching physics from past 13 years. And this is my first effort to teach Cambridge students of AS level. I'm starting with a topic that is of your first unit, and it is physical quantities and units. In this unit, we are having further four parts that are physical quantities, the SI unit, errors and uncertainties, and vectors and scalars. So this is an introductory video just to brief you what we will going to have in our unit, and you will get to know about what is the outline of each topic in this video. So let's start. The first subunit of this particular unit is having physical quantities. Students, what is the meaning of a physical quantity? A physical quantity is something that is physically present and it is measurable. So a physical thing that is measurable is known as a physical quantity. Now, a physical quantity can be of three types. How we can say that it is of three types? Essentially, we are reserved certain physical quantities which are called base physical quantities, and they are well defined. For example, in a French laboratory, usually we are having a platinum iridium cylinder that is of weight, that is of mass 1 kg, and that 1 kg platinum iridium cylinder is a reference for the measurement of any mass that is in the scientific community. That becomes a reference. So that is why we are reserving certain physical quantities which are self-defined. They are self-defined physical quantities. That means they do not require any other quantity to be defined, and they are required for any explanation of a particular quantity. So starting with the base, we will have 7 types of base quantities. The first one is mass. The second one is length. The third one is time. The fourth one is electric current. The fifth one is temperature. They are frequently used quantities. Other than these, we are also having two more. That is quantity of a substance. And the seventh one is luminous intensity. So these are 7 fundamental or base physical quantities, and they are self-defined physical quantities. That means they cannot have other quantities requirement for the to be defined, right? Now, if we am saying that the mass is a fundamental quantity, why I am saying this? The length is a fundamental quantity. Why I am saying this? I am giving you an example with the second type. The second type is basically a derived physical quantities. The difference between base and derived physical quantity will give you clearly demarcation that why we require base quantities as well as the derived physical quantities. Take an example of density. A density, you know very well, is mass divided by volume. So if I am saying that density D, that is equals to mass upon volume, you can see that the mass is there, which is a fundamental physical quantity, and volume is nothing but 3 times multiplication of any length. Take volume of anything. Like for example, for sphere, it is 4 by 3 pi r cube. That is 3 times radius get multiplied. If I am taking the example of cuboid, it is L length, B breadth, and height h. So it's a 3 times that a length is multiplied, you are getting a volume. You can take any example. For example, if I am taking the example of say pressure. So pressure is equals to force divided by area. Now, if a pressure is force divided by area, we will say that Force is itself a product of mass into acceleration, and acceleration further is a product, of, it's a basically ratio of velocity divided by time. That velocity is again displacement upon time, again divided by time. So at core, you will get to know that there will be a fundamental physical quantity, that is a distance, is a kind of length, the time is a kind of fundamental physical quantity, the mass is a fundamental physical quantity. So that is why we require fundamental physical quantities that are reserved or as a base or as a fundamental to define any quantity, and those quantity which require these fundamental quantity in multiplication, in division, for their definition to be defined, we will say that it is a derived physical quantity. So this is the clear difference between these two. One which are self-defined and do not require any other quantity are base or fundamental physical quantity, and those require the other quantities, multiplications of other fundamental or base quantities, or the division of base quantities, then we will say that they are the derived physical quantities. There is one more type, and that is supplementary physical quantities. Why we require them? We have a requirement of the third one just because of a fact that the supplementary physical quantities do not have the dimensions. They only have units, and they are two in numbers. The one is angle and another is solid angle. Probably supplementary physical quantities are not covered in your syllabus, and that's why we are not emphasizing on it. So just switching on the next subunit, and that is SI unit, and the proper units and their conversion we will going to discuss in the second subunit. Now, the second subunit is of SI units. So first of all, we are going through what is the definition of units and what is the definition of a measurement, or what is the process of measurement. It's a core thing, we should learn about it. First of all, I'm taking an example that I'm going to a electrician shop, and that shop is having the electrical wires. Unfortunately, the shopkeeper is not having the ruler with which it can measure the exact length of the wires. So usually what the shopkeeper is doing is he is taking approximate length of 1 feet by taking his elbow, and that elbow is somehow nearly equals to 1 feet. So if I'm asking for say 10 feet of wire, what it does is it takes the wire, and 10 times it measures, or I will say 10 times it compares its elbow, and then cut the wire and giving to me. So basically this particular elbow, as he is taking as a reference, that reference of 1 feet is basically the unit for that particular shopkeeper, and the process of comparison with the elbow is basically known as measurements. So we can clearly say that whatever reference we are taking for the measurement of something is basically the unit, and with this reference, if the comparison is taking place, the comparison which is taking place with the reference, that comparison is called the measurement. You may take another example that in a vegetable market, if I'm going and the vegetable seller is not having a particular weight of something, say 250 grams or 200 grams, it is not, there is no occurrence of that, then usually shopkeepers in the local vegetable market, what they do is they basically take small stones, and that stones are kept in the weighing machine, in the one pan of a weighing machine, and another pan we are having that particular substance which we are particularly vegetable if we are taking. So the vegetable is in one pan and another stone is in another pan. So that stone become the reference for that particular measurement, and that stone is called the unit. The process of comparison with that stone is called the measurement. That's how we are defining the units and measurements. Now coming to the unitary systems. So usually we are having these 4 types of unitary system throughout the world. The first one is MKS unitary system, that is the meter, kilogram, second. That is for mass, that is for length, that is for time. So meter, kilogram, second is the MKS abbreviation. The second abbreviation is for centimeter, gram, second. Then third, feet, pound, second. And the fourth one is system international. That is somehow relatable to MKS, but not exactly the MKS unitary system. Few of the units are different in SI and MKS unitary system, but in our curriculum we are having only the SI unitary system, because system international unitary system is having the authenticate scientific data exchange, and it is authorized for the same purpose, that how a country is exchanging the data with within the scientific community throughout the world. Now, this SI units contains certain conversions, because not essentially a particular country is using a SI unitary system within their countries or within their measurements. They may have some different unitary system. So for the conversion purpose, we are having certain conversions, and that convergence predominantly have certain names. That names are designated for certain conversion factor, that is a number which get multiplied to convert certain quantities into the SI unitary system, or to represent a particular measurement in a smaller manner or a systematic manner. So few of the examples of convergence we are having is DC. Whenever we are having this prefix DC, that means that we are having 10 to the power minus 1 before any measurement we are having. The centi stands for 10 to the power minus 2. The milli stands for 10 to the power minus 3. The micro stands for 10 to the power minus 6. Nano is for 10 to the power minus 9. Pico is 10 to the power minus 12. Similarly, in positive powers, if we are moving, kilo stands for 10 to the power 3. Mega stands for 10 to the power 6. Giga stands for 10 to the power 9. And tera stands for 10 to the power 12. That's how we are having this convergence of particular measurement, whatever we are having. Now we are switching to what is basically error and what is basically uncertainties. Switching to the next subunit. The third subunit is errors and uncertainties. From this subunit, you may have numericals in your board examination. First of all, we are defining what our error means. See, whenever we are measuring certain things, we are measuring certain physical quantities, there may be a chance that we may measure it either a value that is greater than what is the actual value, or it may be lesser than the actual value. So first of all, how we will define an actual value and how we will define an error. This is our motive. See, I'm taking an example that in a laboratory, if some teacher is saying to a students that you need to measure the length of a resistance wire. Now that wire is measured by a particular student as 1.5 meter. Another student is measuring it as 1.52 meter. Another student measuring it as 1.6 meter. Another student is measuring it as 1.4 meter. So if there are 4 students and the measurements are different for each of the student, the number of observations or the number of attempts to measure a particular physical quantity is making an actual value by having the average of all observation. So average of all observation is basically your actual value. So if I'm taking the average of all 4, it will be 1.5 plus 1.52 plus 1.6 plus 1.4 divided by 4. That will give us the actual value of this particular observation. Now, it seems to be 1.5, that is 3, then it comes 6.02 divided by 4. So it comes out to be 1.50 approximately. and that 1.50 is basically your actual value. Now, the measurement you are having greater than this is a kind of error, and that error is called positive error, because it is error which is having a greater value, and the the observation you are getting less than the actual value is basically your negative error, or you will say that a negative deviation is there. So whatever deviation or whatever a change from the actual value you are having, that particular change is called a error, and the actual value is basically average of all observations. So by this you can have a clear picture that what is the exact meaning of error and what is the exact meaning of actual value. Now, how to reduce this error? The error can be reduced by increasing the number of observations. If a true value is there, then definitely it get repeated every time. So if I'm taking, say, total n number of observations, if I'm taking, then basically I am reducing the error to 1/nth times. If I'm taking 10 observations, that means I'm reducing the times to 1/10. If I'm increasing the 10 observations to 20, I'm reducing the error to half times. So that's how by increasing the observation we can reduce the errors. Now, there are two terms which need to be clarified before we proceed, and that are accuracy and precision. When we are talking about the accuracy, the meaning of accuracy is that the accuracy is the nearness, or it is how close you are to the actual value. And precision means how resolution is there. I mean, how much resolution you are having in your data. I'm giving you an example. If a student is measuring the gravitational acceleration, that is a small g, gravitational acceleration. Now, the somehow value, I mean, actual value of g we are taking is 9.8 meter per second square. If a student is getting a value as 9.78 meter per second square, and a student is getting a value, say, 9.6542 meter per second square, then I should say that which value is closer to the 9.8 meter per second square? It is 9.78 meter per second square. So this value is more accurate, whereas 9.6542 is more precise. So the precision lies in the instrument you are, what instrument you are using for your measurement. That will give a good resolution, that will give you how much places to the decimal you are getting the result, but it don't have any concern with the accuracy. Accuracy is something that is very close to the actual value, and that will be confirmed by having number of observations or the observations many a times. This is what the accuracy and precision is about. Switching to the next one, and that are errors, the types of errors. Theoretically, we are defining errors in two ways. One is systematic error, another is random error. The systematic errors are those which are in our control, and random errors are those which are not in our control, that is uncontrollable or uncontrolled. It is called random error, right? So systematic error, we can use the proper knowledge of an instrument. We will have a particular sense of how an instrument is, a particular SOP for an instrument, that how an instrument need to be dealt. We can have the conditions around us. For example, if I'm taking an observation of a particular resistance, then in that scenario, we are having a particular temperature which remain constant, so that the temperature rise must not change the resistance value. So the physical conditions or a particular observer's condition that need to be, I mean, our control. But in case of random error, say if I'm taking 10 observations and another time I'm taking another 10 observations, so there may be a fluctuation in these two sets of readings. This may be due to some random things which you really don't know that what is happening in the instrument or what is happening in your sense about a particular measurement, but it is happening it is constantly changing its pattern. So you will say that those factors which are not known to you and which are not under control to you, you will say that these are the random errors, whereas the systematic errors are those which are under control of yours. Mathematically, they are asking that what are the absolute error, what are the relative error, and what are the percentage error. The question may be framed about the absolute and percentage error. So we will have a small briefing of what are basically the errors are and how the questions can be solved based on absolute, relative, and percentage error. So have a look on it. If I'm saying that there is an absolute error, then the absolute error is usually denoted by, say, I'm having a length measurement and length is given by, say, 7.5 plus minus 0.2. What does it mean? It means that for an observer, the actual value for which he or she is more confident is 7.5, but there may be a fluctuation in the measurement, and that can be of 0.2 positive error or a 0.2 negative error. That's how we are saying that this error which is in the form of addition or subtraction, we will say that it is a kind of absolute error. Absolute error. It is called an absolute error. Fine. And if I'm saying about what is a relative error, then relative error can be defined as, that is in terms of multiplication and division. Multiplication and division. So if I'm saying that according to Ohm's law, if I'm getting V equals to I into R, and it is asked that there is an error in the measurement of current and measurement of resistance is having certain error. So these error can be added in the form of relative error, and the relative error is given in the form of the variation you are getting in the value of current divided by the actual value. Similarly, it is added with variation in the value of resistance you are having and the actual value. This ratio is called relative error. So if it is asked that what is the relative error in the value of voltage, we will simply say that we must know what is the absolute error or the variation in the value of electric current divided by actual value. So, and another is change in or variation in resistance divided by the actual value. If I'm taking an example of exact value, say for example, we are having I as 7 plus minus 0.2 and R is having a value given to us as 20 plus minus 0.4. So in this scenario, individually 0.2 and 0.4 are the absolute errors. And if I'm talking about the relative error can be given from this as delta I upon I will be equals to 0.2 divided by 7. Similarly, R can be written as 0.4 upon 20, that is the value of delta R upon R. Now, if you are adding these two values, delta I upon I and delta R upon R, you may get the relative error of voltage, that is delta V upon V. This is what the meaning of relative error is. Extension of relative error can be done by multiplying it to 100, and that will give you a percentage error. Wherever you are multiplying it to 100, it will give you a percentage, and that's why the percentage error can be calculated through delta V upon V multiplied with 100. That will give you the relative error, right? So this is absolute error, that is in the form of addition or subtraction. Relative error in the form of multiplication and division. If your relation is having multiplication and division, you will simply have the absolute value, actual value, the ratio of which is called relative error. And if relative error get multiplied with 100, you will have a percentage error, right? The fourth part of the subunit of this unit, it is in the form of vector and scalars. So vectors are those physical quantities which are having a particular direction as well as magnitude, whereas scalars are only having the magnitudes. If I'm saying about the scalars, Scalars are volume, scalars are masses, scalars are pressure, scalars are density. These are the quantities which do not require any particular direction to be understood. So if I'm saying that there is a mass of 20 kg, no one will going to ask me that what is 20 kg in which direction. So direction is not necessary for the scalar to be defined. But if I'm talking about vectors, the vectors essentially contains two things. One is direction, another is magnitude. So direction and magnitude both are needed to a vector to be defined. If I'm saying that there is a displacement of 30 meters, then the next question may be asked to me is the 30-meter displacement in which direction, whether it is north, whether it is south, whether it is east, whether it is west. That may be question. That question may be asked to me. So vectors essentially require a particular direction as well as magnitude. If I'm saying that I'm moving with a 20 kilometer per hour speed, then it is a quite right statement, because speed is something that is a scalar quantity, that is distance upon time, and that do not require any direction. But if I'm saying that I'm in an aeroplane and that is moving with say 100 kilometer per hour, 100 kilometer per hour in northeast direction, or I should say that with a velocity of 100 kilometer per hour. So if I'm saying that an aeroplane is moving in with a 100 kilometer per hour velocity, then the velocity term itself contain displacement and it must contain the direction. So that's why the statement is half correct if I'm saying that a aeroplane is moving with 100 kilometer per hour. I must say that the 100 kilometer per hour is the speed part, that is the magnitude part, and it is moving in the northeast direction. That's why a complete statement will say that an aeroplane with 100 kilometer per hour speed and a northeast direction is the velocity of an aeroplane, right? Second thing, if we are talking about what is a vector and how the vector get added and subtracted, then it will create another thing, because it is quite different that a vector is added and a quantity simple numbers get added, because vectors cannot be added easily. The core thing which we should learn, and that is triangle law of vector addition. Triangle law of vector addition. This is the fundamental thing one must know before learning what exactly addition and how vectors get added. Now, we were talking about that vector quantities are those quantities with the direction and magnitude. How we are adding the quantities and how it is different from adding two numbers other than the numbers, how we can define the addition of two vectors. So first of all, we must know how a vector is represented. A vector can graphically be represented in the form of an arrow. The arrow is basically giving you the direction of that particular physical quantity, and the length of the arrow is representing the magnitude of it. Say for example, if I need to draw a 50 kilometer displacement in northeast direction. So what should I do? I will take north and east directions, take a proper scale so that we can have a 50 kilometer represented in within 5 centimeters. So I will take the 5 centimeter length arrow and I will put the arrow in the northeast direction. Or if I'm making it in a Cartesian system and if it is say minus x minus y axis, so I will say that it will be in a particular direction. So depending on your choice of whether you are taking the Cartesian system or you are taking the northeast southwest direction reference, we can have a particular direction that is represented by the tip of the arrow, and the length of arrow itself is basically the scale you are choosing. This is how we are representing a particular vector. Now if I'm representing a vector, in the form of an arrow, then our triangle law of vector addition says that triangle law of vector addition it says that, say, if I'm having two different arrows on a random manner, right? And if I'm joining them head to tail manner, the head means the arrow tip and the tail means this particular opposite of the tip. So if I'm having two vectors and these two vectors are having a particular head and a particular tail. Now first of all I need to do a head to tail arrangement. That means I will put my two vectors into head of one and tail of another in a head to tail arrangement. Without rotating the vector, I'm taking the same direction and same magnitude. I'm just shifting it into its parallel space. The meaning of parallel space is that you are not rotating a vector, you are simply shifting it in parallel side or a parallel direction. You are shifting it. So you can shift this arrow to certain position and this arrow parallelly to certain position. This is how the first thing you need to do is head to tail arrangement. Head to tail arrangement. Okay. Now after having this head to tail arrangement, what you need to do, simply join the tail of a vector to the tip of another vector. That's how you will complete a triangle. And once you are completing a triangle, this side which is completing this triangle is basically addition of these two vectors which you have drawn, that is A and B. Then it is called the addition of these two vectors. The third side is called addition of these two vectors, which is also called a resultant vector, or the sum of two vectors, that is R. R is equals to A plus B. I am putting the arrow just to identify that if a quantity is a vector quantity, a arrow is always there on it. So if two vectors are there, A and B, then in that scenario, resultant vector will be A plus B. This is what the triangle law is. Now this simple law is giving you enormous opportunity to solve problems graphically, or you may solve it mathematically. If I am saying that addition is taking place graphically, then simply take two vector quantities, choose proper scale, draw them in the graph paper and arrange them in a head to tail manner. The side which is completing these two with these two vectors, a side which is completing the triangle, that third side is basically addition of these two vectors, right? Now there is another application of this triangle law of vector addition, and that is in your syllabus, which is component resolution of a vector. Component resolution of a vector. Component resolution of a vector can be done using the inverse, or you will say reversion of this triangle law of vector addition. As the law says that two vectors have a common two vectors can have a addition, and that can be represented by a single vector. That means conversely, if a single vector is there, that single vector can be represented in terms of addition of two vectors. So if I am drawing a vector for example, then that a vector can have two different vectors which is basically get added to give you a resultant vector, that is our own vector. What does it mean? It means that a vector can be represented as an addition of two or more than two other vectors, and all the vectors whose addition is your former vector is called the components of that particular vector. So I can have n number of components for a particular vector, and that is we are saying on the basis of triangle law of vector addition. A vector can have many components or many parts. Addition of these components will give us our own vector, that is A. So if I'm talking about the component resolution of a vector, it means that a vector can be resolved, a vector can be divided into many components. We are concerned about only resolution of a vector in a perpendicular manner within two components. So if I am taking the same example of A and I need to resolve this A vector into two different components that are perpendicular to each other, that means the parts of A vector which are perpendicular to each other, then first of all the parts are known as rectangular components. They are called rectangular because rectangle is having 90-degree angle. So rectangular component means, the rectangular components means that the two vectors which are the components of a particular vector, they are perpendicular to each other, first thing, and second thing, they are having an addition which is equals to your given vector. So if it is say P vector and I am taking it for my convenience in Cartesian system, what I will do is I will put a perpendicular on both the axes x and y, and suppose it is making a alpha angle with the x-axis. So in this scenario, we will say that it is forming a rectangle, and the sides of a rectangle, that the opposite sides of a rectangles are equal. So this side will be equals to your length along y-axis and this side will be equals to your length along x-axis. Now I am taking the privilege of right angle triangle. It is perpendicular, it is base, it is your given vector P. Now I will write simply the sine alpha and cos alpha in these trigonometrical ratio for this particular triangle. Your sine alpha will be perpendicular upon hypotenuse and that's why it will be perpendicular divided by P, and your cos alpha will be base divided by hypotenuse, that is base divided by P. That's how you can have two components. The perpendicular is known as P sine alpha. The perpendicular is known as P sine alpha, and the base one, with the help of cos alpha, base we can write as P cos alpha. P cos alpha. That's how we can have a perpendicular vector resolution of a vector that can be divided in two parts. The first one, with which the direction with which alpha angle or beta angle or any angle is made, will have a cos component, that is P cos alpha, and the perpendicular which is equals to the y-axis can be written as P sine alpha. And that's how we are getting a common conclusion that a vector can be resolved into two parts. If it is say beta angle and if it is a q vector, then in this side with which the angle is made, we will say that it is q cos alpha, and perpendicular to the q cos alpha will be q sine alpha. You can check it by drawing a triangle and getting the value as I have mentioned. So till now we have done the four parts of a unit. That is, the first part is the physical quantity, the second part is SI unit, the third part was errors and uncertainties, and the fourth one is a briefing about what is a vector and what is a vector addition. I think that it includes the outline of a particular unit and it will help you in your studies. If you want more explanation, please text in the comment section. Thank you.